Okay, now we'll cover the topic of segments in Hoops Visualize. We'll give an overview and talk about a few specific types of segments that are particularly important. We'll cover the concept of keys, which are really IDs of how to refer to segments, some typical types of segment operations, instancing, and we'll have an exercise at the end to actually write some code and go through a couple basic types of segment operations. So as mentioned earlier, information in the Hoops Visualize scene graph is structured inside of nodes which are called segments. They contain graphical primitives or geometry attributes which describe how to draw that geometry or how to set up rendering modes or optimizations, and subsegments, of course. So the structure of your segment hierarchy is your scene graph. Segments can also have names, but most frequently they're just referred to by an ID called a key. So root segments are useful to be aware of because a root segment is not attached, and by default attached inside of any visible part of the scene graph, meaning it's not visible on screen or visible going out to a hard copy device or to a file. You can just create segments anywhere you want in the scene graph to be reused later on, and they'll get attached or included into your actual model or view of your model that you want to be displayed. And so it's very, very common to have many different types of segments that are just root segments that contain some information. Windowed segments are particularly unique in that they're associated with a rendering context. They support attributes that are only window capable attributes. And the key point is that only segments that have a window ancestor somewhere up the tree will be drawn somewhere at update time. So we make an update, and if I want to see some part of my scene graph on the screen, going out to a hard copy format or going out to a file, I have to have some of my scene graph underneath a windowed segment. So what these windowed segments do is they encapsulate a virtual visualized window, like a software abstraction of a window, and that gets mapped to an actual window on the device. So there can be an application window, for example, in MFC or WPF or Qt, we would get an actual application window handle, and Hoops Visualize will have a windowed segment that's associated with that. So Hoops Visualize knows to take everything underneath that windowed segment that's visible by the current camera or cameras. You can actually have multiple cameras overlapping, but that's an aside. And anything that's visible under a windowed segment's scene graph visible by its camera will get drawn into the corresponding actual window on that device. And that could be extends to the page of a 2D PDF document or a PostScript file, or it could go out to a file, an actual file, for example, saving to a different file format. Okay, we'll get into cameras later on, but this is just a general high-level concept of how do we see parts of the scene graph on the screen or in other export mechanisms. Keys are a way of referring to any object in the Hoops Visualize database. So every single segment or graphical primitive can be associated by a key. So when a key goes out of scope, it doesn't matter. They have global scope within the context of the application. So the object still exists in the Hoops database, and you can refer to it later on. And so to delete a database, this is a typo here, to delete a database object, a segment or a graphical primitive, you explicitly delete using its key, or if you delete its parent containing segment, it will delete it. So keys, these are not actual pointers to C++ classes. These are IDs to entities in this Hoops database. Okay. And key paths are also important, where actually, I'll do a quick aside here. We can just look at a quick example here on the left. So we talked about root segments, and we're getting into a little bit of sample code. So the HPS segment key is the data type. So I'm going to initialize a new segment key, and I'm going to create a root segment. So I just have a segment sitting out there somewhere. Then I will insert a sphere into that segment, which I've already created, and I'll get back a handle to the sphere, and it's a sphere key. And all these different types, text, etc., are derived from geometric primitives. Keys are derived from geometry keys, and all different key types are derived from HPS key, including segment keys. So we can see our object hierarchy here, all the different types of keys we have. So just like any type of hierarchical class design, you can call any of those methods up the tree. Okay. Key paths are important because they are often needed to resolve ambiguity. So imagine if you've created a root segment and put a bunch of graphical primitives in there to represent a tire. And then we might include or reference that tire multiple times in our actual model. Well, if I go then pick on a specific tire, I need to know which unique instance of that tire I selected. So I need a fully rooted path of keys up through that include link up to the parent segments up the tree. So key paths are something you would work with quite often as you build up the scene graph and interact with the scene graph, particularly selecting, highlighting, querying down the road. So it's an ordered list of keys from a leaf up to its root. The segment key we mentioned a little earlier. All segments are accessed via segment key. Also to operate on child subsegments. And you can imagine many of the common types of operations. The HPS key base class supports a delete. So of course you have delete. But some segment-specific things would be down, say, okay, go one level down, or subsegment will create a subsegment. And flush is supported, which will have a varied set of controls over what types of contents to flush. Everything, subsegments, just geometry. You can even flush just specific subtypes of geometry. So there's a lot of control there. Okay. And then getting into instancing, I mentioned this earlier, there's different ways of instancing. We can instance, we can reference different segments. We can reference attributes, which are a way of styling, just grabbing attributes from another segment. And we also can do conditional instancing. Okay. So this pretty much shows a good picture of what the include segment method will do. So I'm in a currently open active segment. I have a handle to a segment, and I'm going to include another segment. I'm going to reference another segment. So at draw time, Hoops Visualize will go down through the tree and also draw the included segment as if it was part of that, as if it was a subsegment. But the nice thing is we can have a lot of reuse and have a more compact tree, less memory, take up less memory and be more efficient. And again, the key path is useful to resolve ambiguity. And after you do an include, you get back a key of the actual link of the inclusion. So you get back a key to one of these dotted lines. So you could delete that key just to break the inclusion. You're not deleting any segments, you're just deleting the reference. Okay. Here we see key path is covered down here. I'll give a couple examples of why a key path would be useful. and how we can build up a key path, etc. So this is hopefully fairly self-explanatory. This is saying that we can specify that something only being included if a certain condition or flag is met. So if I scroll down here, I think it's a little ways down, we get into conditionals. Thought it was in here. Includes, oh yeah, here we go. Filtering, deleting, conditional include. So we can just define a conditional expression here on the left, and we only include that segment based on that condition being met. And then maybe at some point in time, based on some type of information coming into play, the user picking on something, making some kind of edit, we can set that condition. Once that condition is set, on the next update, visualize will notice, and then that conditional include will become active. Okay. Styling is very, very similar to including segments, but instead of an include segment which references a whole segment or that referenced segment's whole subtree, this will only reference the specific segment's attributes, kind of to get a style, a way of a set of drawing styles. So this could be useful to pre-create a bunch of styles and to help out with defining different groups of colors or different groups of attributes for objects later on. You know, you could build up a material library, a material palette or something like that, for example, in an application. Predefine all these styles and then use them later on as a material picker. There can be name styles, which is just a way of giving a name, and that can be referenced via name later on. That's the recommended way. Let's see. Yeah, and then conditional styles as well. So you can styles can be conditionally activated, just like previously we discussed that segments could be conditionally included. Okay, so this whole chapter here gets into the ways of using styles. So I'll actually just go through a little bit of sample code because we're going to quickly kind of blow through another concept here that we haven't really talked about. So there's basically, and there can be multiple active portfolios, which are this visualized concept, kind of like a booklet of information, a portfolio, right? And so here we're going to define a new wire style inside of this portfolio. And we're basically going to all at once create a root segment, and we're going to give a name to this style called green wireframe. Okay, so now that we have this wire style, we're going to call some other attribute definition methods that we haven't really touched on yet, but they're fairly self-explanatory. We're going to get a way of modifying the visibilities, and we're going to define the style and say, okay, anything that might use the style later on will have the visibility of faces to be false, so we won't see any faceted information, but we'll see edges, so we see wireframe, right? Hence wire style. And we're going to define a color of edges, okay? And then we're going to make that portfolio active, and we have this active portfolio and style. So anytime then down on that segment or down through that segment tree, I can style a segment with this named style, okay? So green wireframe. So that's basically the common way to do it. Conditional styles, very similar to the conditional includes, okay? Define a conditional expression, okay? We're going to conditionally style this segment with glossy red, and if this condition is ever met, then it will actually be styled. And these things can be pushed and chained and a little bit more, made more complex. Okay, so that's all covered in the style segment section. Okay, going to jump to a little side topic here called the view hierarchy. And this will be useful as we get into additional, a little bit more involved exercises and tutorials. So outside of core graphics, Hoops Visualize has some of these sprockets, objects, concepts, where there's a canvas object, and as you see here, a canvas is kind of like the outer level object to represent the outer window. Okay, it's analogous to a window, but it does more than a visualized window type of segment. Like I mentioned earlier, there can be a window key segment. So a canvas can have a layout, and inside a layout, it can have multiple views, and each view can reference a model. Okay, so this does not have to be used. These view hierarchy objects do not have to be used. You could just create a windowed segment and start building up segments underneath and start including segments, and that windowed segment could be associated with a native graphical user interface window on the screen. You could have 5 different native GUI windows for 5 different models that were loaded into your application. But the view hierarchy objects here provide a bit more value and methods and capabilities. So if you start looking at these classes, they'll provide a little bit more power for updating. For example, there can be a fixed frame rate or timed updates are supported by the canvas object. The view object has some higher level utility convenience methods. Again, that one could have built on their own, just from raw segments and attribute the APIs, but some of these are predefined for you. So we would look at the view class. We have various types of fitting the world. We can set up an axis triad, navigation cubes. We can set up some high-level concepts of rendering modes like wireframe. Internally, if you set up a wireframe rendering mode, that's setting up various visibilities of faces and edges and a couple other 5 or 6 different calls. So a lot of these are encapsulating a variety of calls that you would otherwise make on your own. Okay. So this is something that's particularly useful. The view object provides a variety of nice capabilities to interact with the camera and set up different render modes. Okay. This is basically what's happening in the sandboxes. All the sandboxes do use the view hierarchy. They do create these objects. And here's kind of the concept of once we have a view here, a view is referencing a model. For example, if you load in a Hoops stream file, an HSF file, there'll be a model segment will be created, and that view will be referencing that model. Of course, the model segment has maybe many subsegments to represent the model. Okay. So now we'll just do another tutorial. We'll work an exercise. We'll actually work through the fundamentals tutorial, section 1.1, which will have us work through some basic segment operations. And all the tutorials here are designed to be worked through within the context of one of the sandboxes. So you can take a sandbox and start modifying some of the pre-created user code methods, so like on user code 1, on user code 2. So there's a couple little placeholders in the sandboxes to let you work through the tutorials or let you do rapid prototyping or testing of some code. So that's what we would like to do here is we'll work through the basic segment operations tutorial.